Thank you very much. Can everybody hear me? Or do I have to speak up? Just shout louder. Eh? I'll try my best. Good. Of course, it would be a dream if I can give all the information in 1 hour about LNG. So that doesn't really work, right? So I will do an hour introduction. I put some cards out as well if you need some more information. I will be happy to send it to you. Yeah. So a little bit about the stream marine training, because we don't advertise that well. We're basically based in Glasgow Airport, at the airport. So we got our fire grounds over there, we got our swimming pool. We do also the offshore training, MES training, and we more or less work with quite a few companies. We have the boat site about 15 minutes from our building. So we are right at the airport. A couple of bodies we are accredited with are the MCA, of course, for training courses, MNGB for as well. We also have Bahamas approval for, let's say, the polar courses, polar survival, polar navigation. A couple of customers we work with, we also well, more or less as well. We also have here IMarEST, Carnival, most cruise lines. We work with more or less all the cruise lines. Sea Smart in Amsterdam, we do the training, and we actually also trained the MCA. TK, we do all the Yamal projects survival training with. So let's start. So IGF and LNG. So there's two different things. Because when we talk about LNG vessels, we say in the same word IGF, but they're two completely different areas. LNG at the moment has the biggest interest and the most orders of vessels, but there's quite a few more fuels which comply with the LNG or IGF regulations. So the items I would like to discuss tonight are listed here. So why natural gas? Why are we actually switching over to natural gas? The principles of LNG, natural gas characteristics, they're very important because they don't behave the same as regular fuel, which we use on the vessels like diesel and heavy fuel oil. LNG applications, LNG safety, which is quite important, and the containment systems I will address as well, and a little bit about the bunkering. At the end of the presentation, you can ask me questions, and I will try to answer them. I hope. So, why natural gas? Well, that's a good question, right? So why is everybody ordering now these vessels? Well, LNG vessels have been around already quite a few years. So roughly talking about 2010 first ships up to 2014, maybe 10 vessels. But if you look now at the moment what is on order and what is actually operational, you look already in the hundreds. Still very small compared with the complete world fleet. But what is the main reason for natural gas? Well, everybody will talk about environmental, is the first one. Is that correct? Environmental reasons only?
More than that.
Well, actually the first one is quite funny, is economic reasons. Yeah, and that's it. So we're basically betting that the prices of LNG will come down, and the infrastructure of LNG will be there, and then the prices you will see as well. It is actually cheaper than natural gas compared with low sulfur diesel oil. Okay. So economic reasons. Well, natural gas will be at the moment. What we have at the moment available is about 50 years, but we will find the current consumption rates. Consumption rates are going up, of course. You will see China is coming online, India. You see I don't know if you've seen the news, like certain areas where the smog is going high. China, there's a lot of areas where we have heavy smog, and of course there the consumption of gas is going up. But at the moment the amount of gas, roughly 60 years at the date consumption rates, but we're finding gas everywhere at the moment. There's big projects coming online, you see that as well in Mozambique, Australia, but it's more or less all over the world you see big FLNGs coming online. and the gas production is actually going up. So to give you an idea of the prices, I give you the different fuels over here. I don't want to bore you tonight, but at the moment you will see that the current prices are roughly 285 in 18, 260 at the moment. Henry Hub and also Zeebruggen. Why the price difference between these two places? It's the shipping cost, yeah, and that's it. So also storage, but yeah, you're right. It is quite cheap at the moment, but also with what you see from Yamal coming in on the spot market. Spot market is not normally how ship owners actually work at the moment. They basically have to sign contracts for, let's say, extended periods. Why is that? Because there's hardly any infrastructure. So if you see, for instance, Carnival, they have a contract at the moment, Disney as well, for 6 to 8 years, fixed price, and of course the supplier is most likely are the larger companies like Shell and also Exxon. Well, I must say Shell at the moment is definitely holding the most of the contracts. They go for a roughly price at the moment between $6.50 to $7 in MBTU. Yeah. The reason why these oil companies have such a high prices is because the infrastructure, they have to develop the bunker vessels. They have to get the logistics, but when the logistics comes in place, then you will see the prices over years will come down. 2 years ago in Rotterdam we only had one vessel. We already have now 4 bunker vessels. Of course you see Antwerp as well, but the Cardiff side you see the amount of bunker operations they do is very limited. So they're hoping that there's more ships coming in, and then they can do more bunker operations. Also, Anthony Veder does a lot of work for Shell. They have a lot of ships on order, but at the moment it's not cost very economically. So if you see, for instance, the Nova and the Anthony Veder vessel, the Coral Methane is basically shadowing the ship. Well, that's not really beneficial if you have a big bunker vessel shadowing another vessel. But Costa Esmeralda is coming on board, the P&O ship Iona. So like in the next year you will already see that same ship will be starting bunkering multiple vessels. Okay. In general, it's at the moment still the trading is 1 million of British terminal units. It's one of the values we still have. Russians don't like it, so you see always the prices from the Russians in the kilowatt kilojoules, right? But official, this trading standard is still millions of British thermal units, or 1 BTU. It's like a certain amount of calories, and that's good. Okay. That's what everybody dreams, right? Ecological reasons, yeah? So suddenly all the ships turn green. I see the Nova. Fantastic, they have a blue environmental friendly logo on the side, right? Are we all believing that?
No.
No, well that's very good. So let's take that on board, right? Forget about it. There is some improvements in certain areas, but it's not the end and beyond. So it's just a step. LNG will be a stepping stone to other fuels which are coming in the near future too. Push. Good. So ecological reasons. Yeah. So which one are those? Well, we've got 2 types of emissions. First one are greenhouse gas emissions, typical CO2, but also methane. Yeah. So that's one of the ones you have to look at. Yeah. So CO2 and also methane. And then we also have the health emissions, SOx, NOx, and particle matters. Right, SOx with LNG, yeah, definitely a massive improvement. NOx can be managed very well. Particle matters is definitely one of the big ones. Everybody familiar with particle matters? Yeah? Yes, everybody clear? Good, all right. Particle matters, to give you an idea, one cruise ship in the port of Rotterdam produces more fine dust in 1 day operation than all the traffic in 1 week. Right? So when people say in Southampton air quality is not that good. Well, look at how many cruise ships you have on your doorstep. So that might be a giveaway. Yeah? Particle matters, I see as well, is very bad, of course, for your lungs. And that's why you see also now certain cities reducing the amount of diesel traffic, which are more prone to particle matters. But to give it in a real, compared what actually is going on, I must say shipping industry is one of the biggest producers of particle matters for sure. The next one is something you will see in many cases is emissions can be divided in well to tank and tank to wheel. What I'm trying to say here is like when I buy a battery car, is that really environmental friendly?
Yeah.
You see, that depends on if you look at the whole picture or just a small part of the picture, right? And that's what I try to say. And that's a great shift, because where is the responsibility? And to give you that in perspective, I will show a slide a little bit later on with the different fuels, but we first go to the LNG and what the differences are and what the effects are with the different products. So if you look at NOx, you see a normal fuel, you see here also SOx particle matters. You see LNG compared with HFO, is a roughly 85% reduction of NOx's. SO 100% because LNG doesn't have sulfur at all. And particle matters is a reduction of 96. So that looks all very good, right? So far. Yeah? Looks very good. Was also done by an independent study, Ricardo. They did it in 2016. They wrote another report 2 years later, slightly different. But it's a very good report. A bit boring, 170 pages. But it's good information. Gives a good picture. Good. Well, NOx emissions a little bit first. The biggest drivers of NOx, and NOx is extremely dangerous. Well, actually, it's one of the bigger polluters, but more or less transport is the biggest culprit here. So construction side, consumers is very low. Industry can be controlled a little bit. NOx is basically produced and depending on the combustion temperature. Yeah? The higher the temperature, the bigger the risk. But now we have another fuel, for instance, like hydrogen, and hydrogen actually has quite a high NOx, NOx emission. So if you look at the whole picture, we need to look at what the product actually does in overall concept, not just one bit. But NOx is definitely something we have to work on, because this is one of the more dangerous products. Okay, good. Greenhouse gas emissions in general, if you look at this picture, it starts already becoming less interesting, right? I look at here at the CO2 emissions, CO2 annual. I have HFO in the scrubber on a row vessel, and it goes down. Hey, actually I have more. How is that possible? It's a green product. I can have more emissions. And why is that?
That's greenhouse gas emissions, isn't it?
Yeah, no. I look at CO2 emissions per year, right?
Your fuel consumption goes up because of all these scrubbers in the system.
For the LNG, you can have a reduction, yes, but it depends on where the LNG is coming from, right? If I have to send it halfway across the world, I also have to take into account the emissions of the vessel where is it transported, and then that becomes a completely different picture, right? So, having said that as well, you have to look at what actually the reality is. It's the same when I say look at the battery. If you only look at the battery, yeah, that's correct, but if I look at the whole picture, then it becomes a completely different story, right? So LNG by itself does not always reduces the CO2 emission. Yeah? Okay, emission, the total story. Good. So I give you a couple of products here, and there is exactly what I'm trying to say, is who is responsible for what. If you are a ship owner do I have to look at the whole CO2 production or only at what I'm consuming? Is that correct or not? So when I buy a battery car, am I only responsible, and I'm very green because I have the battery, or should I also look at the production of the whole picture to produce that battery, to scrap that battery, and where the electricity is coming from, I'm filling up my car? Yeah? So then I have a couple of fuels here, and we'll go over them step by step. It's not like really LNG awareness, but it gives you an idea of the different products. So what ship owners are doing, they're shifting the liability. They say, well, listen, I only have the well to the tank, right? I only, the emissions, I am responsible by the tank to propeller. So when I reduce that, then I'm fine. Yeah, makes sense? And then I'm green, and I have a big sign on my ship saying that I'm actually green. Yeah? Good. But if you start looking to these ones, and you see as well that LNG, yeah, it reduces, but it depends also where it's coming from. Is it used in Qatar? Okay, that's fine, but if it has to be transported to Qatar, then I have more well-to-tank losses. Yeah? And now I look at the most greenest product in the world, which is hydrogen. That's the greenest product. Or not? Well, actually, the emissions are higher than the other. Yeah? Also, methanol, right? So if I look only at the pictures, yes, my responsibility is gone, but the total production is actually worse. When I look, if I make hydrogen from water, yeah, that's the cleanest product, right? But the problem is I have issues transporting it from A to B because I have it in a gas form. So now I have to liquefy it, and that would come as an addition. Yeah. So these products as well could be also synthetic LNG, which you can make with hydrogen. Would be a bit more, but one of the most important one who has a very low CO2 content is, and I will read it out from you, methanol from black liquor. Anybody familiar with black liquor? Please do Google it, and you will be surprised because most environmentalists will basically chop your head off. Black liquor.
So what is black?
What is it?
Just Google it.
But you're here.
Find out. But I can tell you that there's coal in it. You can make it with coal.
Is it organic compound? Black liquor.
Yeah, it comes from the pulp industry, a lot of from the pulp industry. Good. But some food for thought. So look at it as well. Hydrogen, that's a project I think is now going on between Australia and Japan and China as well. They want to transport hydrogen to Japan and China. Very clean, hydrogen is very clean. Well, it comes from Australia, and they make it actually from LNG. So LNG, actually, most hydrogen is actually made from LNG. There's a lot of production in the States as well. Most of them is made from LNG. And then transported, then you can mix it now as well with toluene. And you basically shift it with a tanker to hydrogen, you extract the hydrogen out of it, and then it's very friendly. But the fact is you need to look at where the origin is. So if you take a look at the overall picture, it's not a very good idea to make LNG from hydrogen. Yeah? Okay. Next one. In the shipping industry, everybody is familiar with the 2020 emission regulations. Yeah? Some people have nightmares about it, other people not. But there is a couple of things you have to be very careful. Because everybody thinks that a dual fuel ship is actually operational, always ready. It's not. Huh? Because if you look at the tier systems of an engine, more or less, when I have an engine which complies with tier 1, in the IMO regulations. The California regulations are slightly different, but tier 1. Then I have to comply with these emissions. And how do I comply with these emissions? It's done on the test bed. On the test bed, it's in perfect conditions. That means that I all do the maintenance. But if I go in operations, soon you will find out that I'm not complying, or just barely make it. The stricter ones as well are the tier 3, and everybody's talking about tier 3. Ready, yeah? Most engine manufacturers are basically lying.
Yeah.
Right? Because they say we can meet the standard of tier 3, but you have to run it on LNG. And that's a problem, because when I start maneuvering and I switch over to diesel oil, I'm not compliant with IMO. And you made a good point over there earlier. We have the problem at the moment with maneuvering, so especially not the diesel electric, but the fixed shafts, right? They have problems with maneuvering with LNG. They don't get enough power out of it. Well, then they switch over to diesel oil, but they're not compliant anymore. Yeah? So that's something to think about as well. And it took a long time. For instance, the Viking race between Stockholm and Oslo. It took them a long time to actually get the captains to work with LNG during the whole process. But most of the companies, they switch over to diesel oil. Having said that as well, LNG, we meet these targets. And 2 months ago, I was always told that you could not start a ship on an engine on LNG. So I have to start on diesel. And then when I'm 35% and I have the temperatures up in the engine, then I switch over to LNG. Right? Till 2 months ago. And suddenly I see the smokeless start engine. And everybody now makes a smokeless start, but people tend to forget what I see. You won't see any smoke, but what is actually coming out of the funnel. Right? Because this is one that is done on the test bed. Yeah, that's correct. That's with the ideal temperatures. But it doesn't say with the startup, so there will be an issue. And then of course, when I start measuring, it looks much better when a cruise line starts an engine and it doesn't come a pop of smoke out. So that's ideal. But we need to see actually if that's emissions actually complying with the regulations. Because if we don't, then we have to bear this in mind, that any leakage of methane, which is methane slips, methane slip by bunkering, methane slip to valves which are leaking, any methane I put in the atmosphere is 25 times worse than CO2. Right? And if I go with my temperatures very high, right, and I get NOx, that's 290 times worse than CO. Right? So that's something I have to avoid. Right? And the NOx emissions, if you can see as well, between tier 1, 2, 3, you will see that the NOx goes down, but you have to do something for it. Right? Nothing comes for free in this world. So if I want to reduce the NOx, I have to increase the amount of fuel. Right? So the amount of kilograms per kilowatt increases. And that's the only way I can reduce my emissions, to keep my temperatures as low as possible, and that the high end of the combustion temperature doesn't go above the maximum temperatures. Okay, so IGF code, and that's more or less a code. IGF code, everybody familiar with coded vessels? Well, you get a coded vessel if there's certain requirements which cannot normally comply. Well, of course, we've got Lloyd's, we've got the MCA, so everybody knows lots about it, right? But we figured out that one of the big problems is with LNG is it misses one item. It's basically our old fuels with a flash point below 60 degrees. So we can't really, we needed to get some different setup, right, for these vessels. So we need, a code was developed. I think it started in 2005. It took a couple of years, and in the end, it took up to 2015 it was adopted. In 2017 it came into force. But what is the problem with this code? Well, I got Lloyd's here. What is the problem with this code?
Nothing wrong with it. It's perfect.
It's perfect, right? But we forgot a couple of things, right? The industry is developing so quickly that there is nobody who can keep up with that code. And that's a big problem. So by the time they got this in effect, there were two products or more or less on the market. One was LNG. So people thought about LNG. But then we got methanol. So methanol is in the pipeline to come. There's fuel cells, which I think we're going to get next year, 2020. We get a chapter in it. But in the meantime, we got hydrogen, we got ammonia, we got LPG. There's already ships coming out with it. Synthetic LNG, that's not discussed at all in this book. Yeah. So, and as we go as well, like the idea of this is that there's a goal and an approach to provide mandatory regulated provision for safe and environmentally friendly use of the LNG as a fuel. Yeah. And what we're looking at is on design, the arrangement, the installation, the control, monitoring and operation of the machinery, equipment and systems using the LNG as a fuel. And to minimize the risk of persons on board, the environment and the ships, structural strength and integrity, all taking into consideration the nature of the fuel used. Yeah, okay. So it came in effect 2015. 2017 became mandatory. So after 2017, people who work on these vessels have to be trained, right? So with, they are more or less as a basic and advanced training. Ships before 2017, when they get retrofitted, people have to comply with that. But you can still come on vessels which are built before and IGF were before 2017, but crew members basically were not really having the tickets, and it's not mandatory. So, IGF code states, low flash point fuel means gaseous or liquid fuel having a flash point lower than otherwise permitted in the paragraph 2 of SOLAS. And the big drive, of course, is SOLAS. You shall never use a flash point lower than 60 degrees. Why is that? Well, it was written down, and it was more difficult to change SOLAS than so you need to have a standard, because if you leave a loophole, everybody will start using it. That's very simple. So the IGF is providing information on gases and other low flash point fuels. Natural gas has by far the biggest attention and practical application in the current and future maritime market. And ethane LEG is considered as a fuel on vessels, operational and under construction. So there is already ethane carriers. They're coming in grains mouths, so that's a bit different concept. But there is no construction details in the following: methanol, ethanol, hydrogen, LPG. And then there's a list like fuels coming there as well. They are not mentioned in the IGF code. Having said that, they still have to follow the other chapters like training, all the requirements for the items that they have on board. But it's not mentioned in the chapter A. A is like the design and construction of the vessel. So, how does it work now? There's already a couple of projects also with the MCA where hydrogen vessels are more or less approved. So how do you guys normally do that? You get class approval, so each particular drawing has to be checked by the class flag state, gets signed off, so you can actually do that. So there's already hydrogen vessels running. One is the one in Shetland, little ferry. It's only 5% mix. Well, okay, that's not real. But there's other ships running already. Norwegians, we have one coming online early next year with liquid hydrogen, and one with compressed hydrogen. Yeah. But the focus is mainly on LNG. LPG has not been mentioned whatsoever. Class already Korean class already approved LPG. Completely different product. Completely different. Very dangerous product. But the reason why the Koreans and the Chinese are very interested is because building a ship which runs on LNG and building a ship with LPG is a big cost difference. The products are less stringent with LPG because the temperatures are substantially different. Okay, so let's focus on the LNG. Okay, fleet development. Basically, look at DNV. They have a live website. You guys use the same to check in. What you will see here is in a purple one, which are scrubbers. Yeah, open scrubbers 80%, closed scrubbers 20%. What is the problem with scrubbers? Yeah, wastewater. Some countries now already say you can't do that anymore. So open scrubbers is already done. And then some places like Singapore, they say, well, if you load, if you have a closed scrubber, well, it becomes chemical waste. So that is basically a problem. But having said as well, a lot of these vessels, they have been building these scrubbers in the last couple of years. They already saved so much money with that. So then the investment is already back. Yeah? But it's not like really a solution. And if you then look at, when was this? This was somewhere in the 611. Now it's already increased. You see 318 ships running on LNG, 141 basically made ready. Most of those ships are not even built. Yeah? So operational wise, maybe 200 vessels. On the global fleet, that's nothing. So it's still in its infancy. But most of those are big consumers, like the cruise lines. They come now quite rapid, but this as well, I said every couple of months you will check. If I check today, you will see this almost doubled already. Yeah? It's going very quickly. Okay. Ethane, ethane vessel. This is Enos. It's a very strange construction. So these ships actually sailing on LNG, but they can also sail on ethane. Ethane, I will come a little bit later as well. It's a slightly different product, different temperature, and the other problem is that the density is higher. So this ship, if you come on board, is quite complex because you see gas detectors on the top of the vessel, in the engine room, and on the bottom, fire protection on the top and on the bottom. It's a more or less quite complicated ship. Most of the time they actually sail on LNG. Methanol. I don't hear many people about methanol anymore. But if you really look at it, it's quite an interesting product because methanol you can put in normal tanks, right? So you use normal bunker tank. It doesn't take too much to retrofit it on a ship. The only problem is if you get a fire, you don't see it. But okay, that's with the hydrogen as well. But there's ways to work around it. It's more or less availability. The Stena, in Germany, there's a plant quite close by. And again, it's like availability of products. Availability of LNG was also a long time a showstopper. Right? Availability of other products will be a showstopper in the future because the infrastructure has to be there. If there is a demand, somebody has to create it, so somebody has to invest in it. But if it doesn't take up, then it takes too long. You see that everywhere. But
isn't methanol a very expensive field?
Not necessarily.
Relative?
It depends on. But what is expensive?
In relative terms to other fields.
Yeah. But if you really look at the prices, if you are in an area where you have to have a low emission, you can use methanol, right? Methanol you can also use in a fuel cell. That's another advantage. Methanol you can do in normal structural tanks. That you cannot do with LNG. So you lose a lot of space on a cruise ship. Space means cabins. Space means other things. And if you really then start looking at it, how much you lose and what you're going to get back, then it's basically a calculation. Yeah, that's how it more or less works. Yeah? Everything is expensive. If you look at the big picture, it becomes even more expensive. Yeah. So cruise ships as well. You have to give up a lot of cabins in order to sail with LNG. Yeah? So anything I can do to get that back is a benefit, because cabin is making revenue. Right? That's no doubt about it. Yeah. But methanol definitely application for the future when it would be available. But it's I agree, it's not a very cheap product, but it can be made quite cheap as well. But it depends on where it is. Yeah. Hydrogen. Quite impressed. Seen this before? No? It was in Bristol. It was the first hydrogen vessel. Lasted like 3 months, this project. Hydrogen is very small. There's like quite a few. Do we have another ones? No. Okay. But there you see as well. Very small scale. What is the problem with hydrogen? Well, compressed, it's very explosive, it's hard to get system tight. It doesn't really like running in an engine, although everybody says that it can run in an engine. It's not ideal, it produces, it's very hard to do the combustion, but it would work in a fuel cell. Fuel cell development is not that great at the moment. There's no real shipboard applications in larger. You see now as well, read in the news, like up to a couple hundred kilowatts ship side, but shore base you can go up to 1 megawatt for fuel cells, but we're not there yet. So hydrogen as well. So what is natural gas? Well, that's a very good question. It's a mix, and that makes it bloody complicated, right? That's something to realize, and it has a lot of. It's easy when you operate from one port to another port, and you use every time the different same gas. It becomes much more complicated when you start different geographical areas, and the product is there is no standard for LNG. It depends on where it's coming from. But the main component of LNG is more or less methane, ethane, and propane. So when I get a bunker sheet, that's another one. On a ferry or if I'm on a cruise ship, I get a bunker slip. I get it from the refinery. I have to take it. I can't take a sample, right? Because it doesn't give me the right information. So I need to see a sample sheet. And then the sample sheet will give me the content for how much methane, how much ethane, and how much propane. And then LPG goes from propane to butane, but I must say as well, in the normal bunker slips I always see some remains of propane as well still available. And then after that it becomes gasoline further down. One of the big things you see over here is that methane has a boiling point of roughly minus 162. So what does it mean?
Compress, you need to compress it to keep.
Yeah, or you have to liquefy it, but I have to keep that at the temperature so it will start boiling off. Right? So when the temperature goes up, it means that I get boil off. It's uncontrollable. Yeah, but you get different boiling points. So when I get an amount of LNG on my ship, right? As soon as I get it in the tank and I get boil off gas, which is only methane, my composition of my LNG in the tank starts changing. Right? So and I have to be able to manage that. Ethane and propane will not boil off, so I have to find other ways to get it into the engine, right? So, and it's not like just using the boil off gas. One of the ships, and I can't say which ship, but it was a passenger ship. They got delayed by 2 months, so they started using the boil off gas, right? And then after 2 months, they wanted to start the engines. No go, no go, because the consistency in the tank already had changed that much. And so they basically had to bunker again and get everything mixed up, and then they were able to start it.
In the manufacture of LNG, where you take your natural gas, you're generally then stripping out the ethanes and propanes in the LNG train. And
No.
You just end up with
No, you get a mix.
methane, 99.9%.
No. I will show you in a moment. You're impatient, but we'll get it. But it's a good question, and it's a very good. I can't strip that out.
But don't they produce methane with biodigesters? You know, there are small units now which are 1 megawatt units springing all over the country. The biodigesters.
Yeah, and I can make pure methane.
Yeah.
Yeah. But that's not what I normally sell because I need much more product. Yeah. So I have to work with a standard for a area. Yeah. I'll go with it in a moment. The problem is that a long time, and it was a bit of a problem. You have different places where gas is coming from, right? And of course somebody screwed it up a little bit, so they didn't get the right amount of trees and elephants and other animals together. So what happened is that you have a big differences between different places. So to take some real extreme ones, I look here at gas originating from Libya. Methane contents 82%. And the density 478 automatically as well, and megajoules per cubic meter. Now everybody asks me every time the same thing, what is the best product? And you know what my answer is?
Calorific value.
It's the gas which my engine is set up for. Yeah. So when BC Ferries, they built two ships in Flensburg, and they tested, they did the sea trials, and then of course they went to Canada, and they couldn't meet the normal speed, right? Well, that's because Alaska has a very high methane content, so they basically had to set up the engines, and that's very easily done. So they set up the engines for that specific gas, right? And then they leave it running. So that's what I'm trying to say. If I am an operator, and that's a CMA as well, they get different geographic areas, you will get different gas. There is no standard as such for gas. Yeah? If I buy from the national grid gas, so if I go to Cryogenic, they have a mixture, so they can mix up some, but it's very limited. So I get a certain gas quality. So in my contract with the gas supplier, I will put a minimum amount, the minimum quality in, because that affects the price. But I can get better and worse. But ideally, I want to have the same gas for my engines, because my engines have to set up in a certain way. Make sense? You look puzzled there. So CMA, with the big container vessels, they will not bunker anywhere, with the exception of France. So they will sail all the way to China and back, and then refuel. And that's for that particular reason. Yeah? The gas content, because if I start altering the gas content, I'm completely lost. Because when I top up in another location, behavior in my tank is going to be different. And that's something we never did with gas carriers. We never topped over the top. Right? So we always kept the same LNG in the tanks. We never went from one port to another port and bunkered it.
So how viable is that commercially?
Huh?
How viable is it commercially from the ship owner's point of view?
Well, basically, I look at what I have available. So, like, let's say I get a contract in, so that's specified by Shell, so there's a medium. So they will get the gas at the moment from Antwerp, from Zeebruggen. So there they have a certain amount of gas coming in. They can do the spectrum analysis. That's fine. It's like a very high-tech equipment. They are basically bunker. Island of Grain is slightly different because that goes in the grid, right? So they need to comply with certain caloric values what they send into the grid. Make sense? So when I get a bunker truck from the Island of Grain, from BOC, you will see the national grid, and that's the same as I get at home with the LNG. But that's a standard they have to get. It's not something. But in other areas, it's like when it just gets liquefied, it doesn't have to be the same. And that's why big oil companies are trying to control this contract, because it could well be that somebody in his backyard starts mixing up gases, yeah? And you don't have any means to check it, right? So you can only see on your engine how it starts behaving. You see your NOx indexes, you see that it doesn't behave real nice, but then you already have it in your tank. And that's a bit of a, it's not like you can just take a sample out and
And just make a point, all these LNG fuel, how do they pump the fuel to the?
I'll come back in a very good question. I will come to it. But remember, when it goes in the tank, I have to manage my pressure.
The reason I'm bringing it forward is that when I sailed on LNG vessels, if we did have a vessel with a cargo which had high ethane content,
Yep.
when you got to the bottom ends, you couldn't pump it because the pump, the spray pump would not be able to pump at that density because the density of the cargo was too high.
Yep.
So that's why I was asked the question, but I'll wait for the.
I'll come later on, but you see, it's not that easy. It's not like a regular fuel. So I have to manage it way more. I have to think in advance and then also see what's going to happen. Yeah? Good. So, definitely different methane content, different density. So that's very important as well when I get a certain amount in my tank and not, so I have to write it down. And then it has a certain megajoules per cubic meters. Yeah, great. Good. So, changing composition will affect a couple of things, and that's something you really have to get in your head, because the good thing is with, well, not the good thing, an IGF tank does not have a sounding pipe. It doesn't. So I have to 100% rely on my automation. And most important ones are my temperature. The temperature is absolute vital, because when I get like a wrong temperature, what's going to happen? Start boiling off. Happened already. So with BC ferries, there's nobody on board. There's only one night watchman. The guy comes on board. At the gate, there's a camera and looks at the temperature of the truck. If the truck doesn't have the right temperature, it goes off, right? And guess what? I was training the guys from Belarus ferries, and they ran in this problem. And they didn't realize it, because it's not so simple to start bunkering. So they ordered 4 trucks, right? And they were in Spain, but you can only have 1 truck at a time in the port. So these guys were sitting there for hours and hours in the sun. Right? So when truck number 4 came in, all the safety valve went off. They don't have any means to control it. Right? Yes, a cruise ship has means to control it. They have of compressors, they have all type of equipment to control it. But smaller, simpler systems, they don't have any control. They pure have to manage with what they have on board. Yeah? So one of the critical ones is the temperature. Of course, the density makes a difference as well. And then of course the energy content, and then automatically the price. Yeah? So the price is normally specified in the contract. And then one of the big things is the engine performance number. If people are used to an engine, so you have an engine which runs on diesel oil, I have a fuel pump, and that's set, right? If I get more load, but the ignition, the combustion is set. With a dual fuel engine, I basically can alter. So I have actually not only my regular fuel pumps, I also have a common rail system. Right? And I can alter slightly the combustion. And one of the items you will see as well, on all the cylinders you have a so-called NOx sensor. If the NOx increases, it will adjust the combustion. So these engines are way more complicated. So if I have a normal engine which looks exactly the same as any other one, and it's a Wärtsilä DF engine, you can have roughly 20 different options. That's all I say. Yeah? So as an engineer, you really need to know what engine you have and what it should do and what it can't do. Yeah? Because I have often now already see people and they say, well, we have problems with our injectors. Yeah, but what system? Is it in your normal diesel mode or in your gas mode? Right? So that makes a big difference. But the engines are way more complicated. And that's just a fact. Yeah? But remember what type of engine you have. Okay. Okay, a couple of other things from comparisons. So LNG has more megajoules per kilogram. Yeah, that's correct, but the problem is I cannot get these kilograms in the engine, right? So compared with heavy fuel oil, the master on the bridge, if you had like same conditions, right, gets more power with heavy fuel oil. Does it make sense? Okay. So when I switch over to diesel oil, I have a little bit less power. And then of course when you go to gas, he has a bit less power, right? But the problem is you have a dual fuel engine. So what will the captain say? Can we switch, chief? We go to diesel oil, yeah? Because then he has more power with maneuvering, right? So when you really look at it, you have to be careful. Only gas engines are the solution, because then the master can't change anymore. This thing, yeah? So, but if you have this option, be aware, right? And it's also it's a sticking point with a lot of companies, because most engines, MAN and Wärtsilä can have, but MAN engines are definitely not tier 3 engines. They're only tier 3 in gas mode. Okay, difference with well, cabin. So I'm going to lose heavy fuel tanks. Heavy fuel tank. When I compare it with LNG, I need roughly 189 times the volume from LNG, right? But that's a square tank. I have never seen a square LNG tank, no, coming to you. So they're cylindrical. So remember, when I have a cylinder, I lose way more space, right? So that's why you sometimes see these ships as well. You have cylindrical tanks, but you can also have bilobe tanks. So 2 halves are together to gain more space back, right? But in the end, it's not a very good solution. The only solution you can actually have is that you go with membrane tanks. And membrane tanks can be square, but you still lose the space of the insulation. You need still have the insulation. So the container vessels, also now Poland expedition vessel, they will have membrane tanks, which is a big step. It was not available for the cruise ship yet. Meyer shipyard didn't like it at all, and it was just approved last year. DNV was the first one who signed it off for CMA, and now Hapag is also retrofitting. Yeah, and the old difference, 175 the volume. So okay. Other problem you have, of course, is that you're quite easy to say that as well. These ones are structural tanks. The LNG tanks are not. Right? So that's another loss as well. Yeah? So you need also excess space, so it's not that simple to organize. So you lose quite a bit of space, a lot of cabins. Good. We'll quickly go over this. Won't spend too much time on it. Methane number. Everybody familiar with methane number? Methane number is just a fictive number. Yeah? Pure methane in an engine is called 100. Yeah? So it runs with pure methane. The methane content is 100. Pure hydrogen is 0. So that already says automatically that hydrogen cannot be used in an engine. Although, when I Google on the net, I see that it's possible. It's possible up to roughly 20%, but after that it becomes really cumbersome. Yeah? And it's in a normal four-stroke engine, it will create knocking, and that's one of the things as well. If you don't have pure methane, ethane you see is 44. If this drops off, the knocking sensor has to be adjusted. Yeah? Otherwise I would get knocking in the engine. Yeah? So the key is, until all the engine manufacturers, they're working very hard. I hope by the end of the year to have a standard for this methane number. But at the moment, when I get my gas, I have to go to my methane calculator from the respective engine manufacturer. So I go to Wärtsilä, I put my bunker sheet in there, and it will give me my methane number, and it will tell you, yes, you can use it in the engine, and the knock index on your engine should be this. Right? If you're going out of these set points, it will basically tell you call Wärtsilä or call MEN to see if you can use it, yes or no. Yeah? Knocking. Good. So next one is cryogenics. Okay. More or less the dictionary definition, and you can search it as well. Signs of cryogenic is the temperature below -100. So that excludes LPG. Yeah, it does, because ethane as well is like -80. So technically it's not cryogenic. Long story short, it's very cold. I would say anything below -75 is cryogenic, because the damage it does is fine. But it is very important, because the lower the temperature gets, the bigger problem I'm gonna get. Yeah? What type of problems? Yeah, no, it's maintaining it. It's like insulation, but also the materials have way more like a test regime. It's way more complicated, even simple PPE. At the moment, there's hardly any PPE for liquid hydrogen. Yeah? If you see the requirements to go to -253, there's very few products who actually can sustain that. Yeah? And that's what I said as well. If you go to roughly LPG, which is -80, the requirements for the equipment, for the valves, for all the automation is way less stringent. Yeah? When you go to the liquid hydrogen, a lot of temperature measurement equipment can't cope even with it anymore. Yeah? So how to make a cryogenic liquid? I will go over that slightly. We mentioned it as well. Starting point is natural gas coming from natural sources extracted from Earth. From organic waste, bio-LNG, there as well. That's it's getting more and more now these days as well. Also from flare waste, you can use flare waste on the oil rigs. And then the LNG liquefaction principle, the gas is purified by removing any condensates. It's water, methane, oil, and then CO2 and HS2. And more or less I go down to the cool down process. So how does it look like? You have here one in Trinidad and Tobago. Trinidad and Tobago is an island, yeah, they have gas, so I have to liquefy it in order to ship it. Make sense? It doesn't make sense to liquefy it if you can send it over with a pipeline, because it's a much cheaper solution. So from Russia to Europe is a pipeline. But if I'm on an island or like even Australia, you need to liquefy it to transport it. Basically, the cool towers, and you clean it up, comes to the storage tank brings it to the Yeti, and then you get basically the areas can be shipped to the final destinations. Well, did a little bit more. You get transportation by pipeline. You get the treatment. Also, one of the most important things, traces of mercury. Mercury, although aluminum is a very good product, it doesn't like mercury very well. So you will see in a lot of cryogenic systems where they use aluminum, it's often on the outside, so you can actually visually inspect it, because otherwise you can have a chance of aluminum mercury corrosion. Yeah, and then it's ready for transportation and shipping. As a ship owner, am I also have to look at the CO2 footprint to achieve this?
Green.
Huh?
Depends how green you want to be, claim to be.
Yeah, but I see this super green now, and you get the blue green. So like, I mean, you can make it as green as you can be, but it's a bit like the Volkswagen, yeah. You can adjust. But that's something you have to bear in mind. It costs a lot of energy to produce the liquefied LNG. Okay. So what is LNG? Well, very simple. It's UN number 1972. It will never change. Yeah. So that's it. It's set in the United IMarEST code as well. That's the product, and that's it. It's a liquefied gas. Yeah, that's as well. Remember, every time I mention it, it's a liquefied gas. It wants to go back to its original state. If you lock it up between two valves, you have a massive problem, right? Like with diesel oil, I can close two valves, but I always have to think this is gas. So it wants to go back to its original state, which is 600 times bigger. LNG is natural gas that has been cooled and condensed to a liquid at atmospheric pressure, has a roughly minus 162. Minus 162, I always said it, when you look at the MSDS sheets, it's a range because it depends on what the mixture is. So how much methane, how much natural gas, and also is colorless and odorless. Why? When I go at home,
We mix acetone, I think, to make it odor.
yeah, pectin, like that. But I can only do when it's evaporated, right? So it's no point to do that when it's liquefied. Now the IGF code didn't specify the same as shoreside. Because shoreside, I always have to add gas after it evaporates. Doesn't even, like Island of the Sky as well, they have now a fish factory over there. They basically have an odorizer there. But the IGF code doesn't ask for that. Yeah, they should. It's fun. But you can't smell it. It's quite interesting because I started my career with Shell with a colleague, and he said, I never smelled anything. I said, yeah, that's right. He said, well, he thought we never leaked, but trust me, we leaked. Okay, so in gaseous form and odor and deserted, yeah, and the safety benefits. But having said that, still 20% of people are like slightly smell deaf or really smell deaf, so they wouldn't even smell it anyhow. It's non-corrosive and non-toxic. Yeah, so I don't know why you have to inspect the tanks because it's non-corrosive and non-toxic. It's absolutely non-corrosive.
But it could get stress corrosion effect, couldn't it? The tanks due to.
Yeah, the stress on the, but I can see that on the outside. I've never, like shoreside, we never do any inspection. We do everything on the outside. And after I've seen tanks, well, my brother was tanks 40 years old, and it like looks like new. Good. All right. What is liquefied gas? Well, more or less a liquid which is left alone in the atmosphere would boil off. Yeah, that makes sense. So if I put it here and I would put a little bit of nitrogen or LNG in it, it would boil off. That's it. So it wants to go back to its origin. Physical properties. LNG. Natural gas. Yeah, that's it. roughly 600 times. So it expands 600 times. Yeah. So remember, you can utilize it as well, or it can really work against you. So if I lock it up to between two valves, I need the safety valve in the middle. So, but always have to realize when I close the valves, is there any LNG in the pipe? Yeah. But I can utilize it as well to drive out the liquid, because I can close the valves, build up the pressure, and basically move it up. And so that's has a pro and a con. But that's more or less where it wants it. LNG is lighter than water, so it floats on water. That's good. Yeah. So when I have a spill in the water, not a problem. Will go up. Yeah. LNG density is 450, water density is 1000. So it will float on the water, but it's also a disadvantage, because what you think is going to happen when it floats on the water? Yeah, and what do you need for evaporation?
Heat.
And where does it get the heat from?
From water. Water becomes ice.
From the ship, which is like laying next to it. Yeah, so it will pull the heat out of the steel. Yeah? So just be aware as well. It can cause brittle fracture. I will show you some nice pictures after this. But that's where the heat comes from. That's the disadvantage when it's floating on water.
So you will say it chills the water to such an extent that the metal can be affected with a brittle fracture.
Yeah. Yeah. A couple of other things which I'm not going to go into depth, but a couple of products you cannot use for fighting fires with LNG. Well, foam, because density, right? So it will float. But having said that, you can use water if you get LNG on the deck to segregate the water. You flush it with water, and the LNG will come off the deck. So it's a protection as well. But foam you can't use either, but it's only when you use very low water content foam you can actually use it. So you see, shore side you will see the big foam operators. Good. It's not soluble in water. Yeah, by nature it doesn't like that. And at temperatures above minus 110, vapor is lighter than air. So, what will happen normally? Everybody has seen this curve. If the temperature is low, when you see it coming in a bucket, you will see it first coming down, and then it will elevate. Right. So if you get a spillage, you have to make sure as well that the drains in the bunker stations are basically avoiding that there is any gas coming down. Normally, what they do is they put temperature sensors in it, but we can by design make it in such a way that when it comes out, that it can be released again. Yeah. Okay. So relationship: raise the pressure. Raise the boiling temperature, yeah, that's clear. And lower the pressure, lower the boiling temperature. Yeah, and that's very interesting when you see the watchkeepers, because suddenly when they reduce the pressure in the tank, you see the level going up. But you don't get more LNG, but that's the gas law. It's not like because a diesel oil tank. A diesel tank, you don't have that. Yeah? Okay. Flash point, basically, you said it as well, flash point below 60 degrees. Well, what is flash point? You put heat in it, closed cup, there's still air in it, you have an igniter, and at one temperature it starts, the vapor will start to burn. Methane, minus 188. That doesn't make any sense. Boiling point is minus 161, and flame point is minus 180. Well, one has nothing to do with the other. The fact is, vapor, even if it's minus 188, is when it gets spark ignition. Right? So what do? We make sure that there's no oxygen anywhere in the LNG system. So how do we do that? Yeah, we use first nitrogen, and then of course, then after that, we drive the nitrogen out again. So there's only LNG in the tank because I don't need any alcohol. That's often the mistake they make with bunkers, and I must say that's why I agree that sometimes tank inspections are required, because when I connect the bunker hose, I have to go through a whole process to get that bunker hose and the moisture out of that hose. And so I first use use nitrogen, either gas or liquid form, and then I purge it out, and then I can start using the gas. If I don't do that, then I get water. Okay. Flammability. Flammability is basically gas is flammable. Yeah, that's everybody knows that, right? So that's just a given. Yeah? Well, that's more or less done by fire testing, because materials that will not burn, water. Is that true? Exactly. So that's why when you say fire testing, you need to make it's just a definition, but it's not all and beyond. So like that as well. But we know that gas is flammable. Yeah. So okay. Another one which is very well, we can argue about it for a long time. Natural gas auto ignition temperature. Auto ignition temperature is more or less the temperature a product ignites in an engine, yeah, with a diesel process, right? So we don't use any spark plug, just compression and ignition. You see diesel oil, 260 to 3700, and well, that's what we use in a diesel process, right? We use diesel oil. Could I use gasoline in a diesel engine? Exactly. So, but you could technically do it, but sometimes the knocking comes because of pre-ignition, or sometimes late ignition. But you could get away with it.
Won't do much for your big ends or your back.
Exactly. Well, one of the things is, well, you see natural gas, you don't have that temperature. So natural gas cannot be burned in an engine by itself, in a diesel engine.
Even with a high compression ratio, it cannot be.
Absolutely not. Not possible. If you, like, LNG is not like LPG. LNG is a very, very reluctant to burn product. If I have a Pyrex over here, I could light it and put it right in front of you. It looks like a wax flame. It's too rich, too poor. The rich is not a very good. So I have to assist it. How can I assist the combustion? Spark, but it's an auto process, yes. So then you can have a pure LNG ship, yes. Or
Pilot fuel with diesel.
diesel, yeah. So I still need a diesel pilot system, which basically creates the ignition, combustion, before the main combustion starts. Right? So the engine does not run on gas. So the dual fuel mode means it can run on diesel or diesel gas. It's about 5%. Right? So I have those emissions as well. So when only a pure gas engine can work with a spark plug, you need two means of injecting the gas. The pilot gas gets ignited, and it's not a simple process, and then you will get a clean combustion. But otherwise, you need to assist it with diesel. Yeah. Okay. So LNG, a good energy source, fossil-based fuel. So that's what people don't like. Yeah. Boiling point is approximately 162. It's cryogenic liquid. It's a natural odorless and colorless. LNG is not flammable natural gases. Yeah? So that's another misconception. Okay. One of the other ones is, I'm not going to go into depth, is flammability. Right? So we basically, the flammability range is basically set in the MSDS sheet. 5% for LNG, 15 is the top value. Guess what petrol is? 0.5. It's here, yeah? So this whole mixture is not very complicated. It's not a very difficult process. If you see other products we have on board, like acetylene, it's 5 to 75. So there's other products as well. But as long as I can manage it, the system by itself is automatically designed that at 20% LEL, the gas detectors, which are located in most spaces, will basically give an emergency shutdown 1, meaning give an alarm. And at 40% LEL, it will basically shut down the whole system. Isolate the system, switch over straight away to diesel oil, nobody gets injured. You wouldn't not even notice that the engine switched over. Of course, with an exception of the alarm, but on the bridge they wouldn't even see it. Yeah? Another way of working, right? You can see that as well. If I want to stay out of this area, on gas carriers, of course, I go all the way down to 0. And I don't have any oxygen, right? But on cruise ships, we start now using that, in some other ships as well, you use an oxygen deprived area. So our bunker system is basically with a reduced oxygen. So we reduce it till roughly 12%. The bunker station. So it's semi-inert. The tank connection space, 12%. Why is that? well, then I will never be in the flammability. So is there any escape for gas? It still won't affect me. So if I go in the bunker station, I basically first have to press the ventilation. It will basically replenish it with the oxygen, and it goes from there. There's another reason why that doesn't go further than 12%, but it is related to gas detectors. Yeah. So we can basically protect the space as well. Good. That's a weird picture, right? Anybody worked with Shell? In your life? Any Shell employees? Ex-Shell? This is a gas tanker, the Cryogenic. This is 180 tons of LNG, blast over the site in 10 minutes. Everybody looks very surprised. Cryogenic. Just Google it. It's on. It's a very old one, but they did it in the 70s to check if it was okay to jettison LNG safely off the vessel. Okay, but we learned a lot of things because now, because they took sensors and stuff, we know in an open space if this is 180 tons, right? This dissipates within 14 minutes. It doesn't come far from the water, but the one thing which is really important is the flammable area is very small. So the flammable area is inside the cloud. If you're standing outside the cloud, you can have a cigarette wherever you want. It will not ignite, right? So, but that's great. So a couple of tests. So this was the Gedilla, and then after that they did Nevada Desert. They did a test as well, but that was more like behind an obstructed wall. But yeah, very impressive. I don't think you get away with it anymore. But it was a good test. Learned a lot. Good. So, what type of materials actually can handle these cryogenic values? So you see medium temperature melted steel 0 degrees. That's lovely. Arctic steel minus 55. Aluminum can minus 163. Invar, yeah, also minus 163. And then Arctic stick 163. That is roughly there. So when I go to colder, I need even more stringent. Like stainless steel is more or less the better solutions. But we start now working as well with these Arctic steel tanks because it's easy to manufacture. Okay. Yeah. See the cracks? So that's brittle fracture. See if I have another one. Yeah, brittle fracture. Yeah, so exposed the steel to the, and the problem you're going to have is that if a product is exposed to cryogenic, you do not know if it still retains the same mechanical values after that. So that's also an additional cost. So anything I buy which has a cryogenic value, so like if I buy valves or gasket material, all has to be tested to check if actually the material structure actually permanently changed or not. But it can do serious damage. So that's to avoid it. Good. Okay, are we still doing good for time or
Yeah.
how much?
Keep going.
Oh, I'm doing good. Good. All right, LNG supply chain at the moment. The most important LNG carriers have been around for 70 years. Right? So let's. No. We had not a single accident. You believe that? No, because oil majors call it incidents. Right? So it's not an accident, incident. There has been some incidents. When you do the course, I actually do incident as well. So okay, it's likely more, but yeah, there have been issues. Big car carriers, all quite old, 70 years. This is more or less new. The smaller LNG fuel stations, CNG fuel stations. You see them now coming up, new event, you see them popping off right, left and center. So that whole market is starting to develop. LNG bunker vessels. Well, 2 years ago there was like a couple, and now we're getting them everywhere. So it's going quite quick, a lot of under construction as well. Okay. Good. Next one. IGF Code Chapter General Arrangement Goals. Principle of segregation. So what we do is the main philosophy, we segregate gas from normal operating areas. It's a bit more complicated than a gas tanker. Gas tanker, when I read no smoking, I'm standing in a dangerous area. right? The gas is on the front. Right? In these vessels, right, is it like a cruise ferry or like a passenger vessel? It's much more difficult because I can have cabins next to the bunker station. Can I have a cabin next to the bunker station? Oh, wait till you see the Iona. You can have everything next to the bunker station. And next to the tank, by the way, for that matter. As long as you de-risk it. So everything has to be de-risked, right? So the words you always hear with these LNG vessels is Hazardous and Hazardous. They are basically crucial, but we can de-risk everything till there is no issue anymore. But the idea is that there is segregation of tank areas, engine spaces, vent areas, and no direct communication between gas spaces and non-hazardous areas. And it has to be always reinforced in a 60 and a coffee dam. And in hazardous area classification is segregation of piping systems. So hazardous, I don't have a picture of that. Hazardous zone have to be located, have to be shown on a separate door. It cannot be on the fire plant. Right? Why not? Okay, first of all, you don't want to let the crew members know that they're actually living in a hazardous area, but that is not the point. The point is, the hazardous zone are only done during normal operation, right? Only normal operation, but the safety plan is done also when there is an issue, right? So when there is a collision, I have to work. So I can never show it on the safety plan, right? Because the hazard area will completely change when I have a collision or a grounding. Make sense? Yeah? It's good to have a look at these drawings before you actually enter the vessel, but it can change. Yeah? When we start doing maintenance, this hazardous zone can change quite substantially. Yeah? Other good thing is like the fuel pipes in the engine room, they normally are double wall. Double wall, two type of options. First one is gas on the inside and an inert gas, which could be nitrogen with a higher pressure on the outside. So I get a leak, higher pressure, I will get an alarm. Emergency shutdown. Nitrogen will go into the space. Yeah. Second option is exhaust ventilation. I have a 5 bar. I have an under pressure over here, basically extract to the funnel. I have my gas detectors on regular intervals. I get a leak, means the gas goes in the second pipe, and it will basically trigger a gas detector. Gas detector 1 will be fine. The gas detector 2, chuck, everything stops. Go to safe mode. Yeah? Yeah. Good. All right. Simple fuel drawing. Yeah, you good? Yeah. Simple fuel drawing. Yes? No? First time I saw these LNG fuel drawings, I thought, my God, that I took the wrong job. It looks really, really complicated, doesn't it? So what you always have to do when you see these drawings for these LNG systems, you have to basically reduce it. So I got my bunker station here, and I got my tank connected in space. Good. I'm gonna reduce it further. Oh, it's nothing left, right? Yeah? Quite simple. But why is it so difficult? Why? The reason, as I said as well, I cannot lock up my LNG between two pipes. Well, you see certain valves, right? So automatically I need a safety valve. All these safety valves are interconnected. Right? I also have nitrogen purging. So this is a normal bunker station, right? Basically has a pipe coming in, but you see here pressure, gauge, temperature, they're totally irrelevant. That's the problem with AutoCAD. It's like you don't see the difference between the sizes of the diameters, right? So you really have to look into these drawings, right? In the end, I go for this one. It's quite simple, right? So, what is different between a regular diesel oil tank and an LNG tank? All right, good. First of all, I have a filling. Well, I have the diesel oil as well. And now I see two different connections. I see one here on the bottom and one here on the top. Why is that?
To inert it, is that why it's filling?
No, no, no. There's no. This is only natural. After I have inert the tank, I drive all the nitrogen out, and that's it.
It says it in the drawing.
You can spray it in order to control the temperature.
Ah,
Space.
not only. That's it. But really remember. So there is a relationship. When I fill up the tank, what's going to happen? I reduce the volume. So what happens when I reduce the volume?
Temperature increases.
Pressure.
Pressure goes up, right? So I have to, at one stage I stop. So when I top spray it, I reduce the temperature. What happens when I reduce the temperature?
Pressure.
Reduce the pressure. Ta-da! So that's the main difference between when you see it compared with a regular diesel heater. On top of it, you see as well, and you ask me the questions, how do you do that with the pumps? Well, with the Wärtsilä system, fantastic, I don't need any pump. It's the best system ever, I don't need pumps. Right? Anything with cryogenic and pumps is not a very good solution, right? But Wärtsilä figured this one out. Most ferries, you don't need to do that. So what they do here, how do they control the pressure? Well, they basically drive the mix of LNG to the vaporizer to the engine, right? So that's fine. But how do they achieve that? Well, very simple. They have a heat exchanger here, right? If the pressure goes too far down, basically the valve is opened up, puts a bit gas on the top side, and basically controls the pressure. It doesn't work for cruise ship because of the high demand. So they need physical pumps to pump it to the engines. So they have cryogenic pump inside the tank, which is a really bad solution. Can also do it outside. But like Iona, they have two pumps, cryogenic pumps inside the tank. Guess how much a cryogenic pump costs? Like this size. Huh? Take a guess.
Over a million. I think.
250,000. Simple overhaul, 14,000, by the way. Hey.
I'm making it.
Ta-da-ta-ta. And Vanzetti, they will do the overhaul, but you have to bring it in their workshop. So that's another one which we haven't figured out yet.
What's so special about this system, multi-stage pump, isn't it?
No, they use a single, like they lose low pressure. If you go to Maggie systems with high pressure, it's like the MAN Maggie system where you inject it, there they go to 600 bar. Those pumps are a little bit more expensive. A little bit more expensive. But they use low pressure 4 bar. It's quite simple.
So what's the prime mover for it? It can't be electric, can it? Is it a
Yeah,
gas?
electric. Electric. The problem you don't have any problem with the installation valve with gas because it's completely inert. So it's not rocket science. Good. This unit is that unit. Looks big. Well, you can make it any size you want, right? You can put it in a tugboat or you can put it in a cruise ship. This is the tank, vacuum insulated tank. Basically, you have a vacuum in the inside and between the inner and outer tank, right? And then all the equipment is in this box. What do I see in this box? A gold mine. An absolute gold mine. Yeah? So that's how it looks in the inside. Very nice stainless steel, very good shiny. That's good. You got, because it's and then you see all the control valves. 20. Very expensive. Yeah. So but that's how it looks like. So when it comes basically as a unit. Okay. This is the whole unit. Basically, you put the unit in place. You only need power, a couple of heating pipes, a little bit of electric cable, and then to the engines. And that's it. So it comes completely as a unit. Yeah. Okay, so the last one, and then we're done. Bunkering. Bunkering, yeah. What is the problem here? What is the problem?
Liable to go bang.
No, but I mean, what is the problem? Does it look any good? No? Quite normal, this? You've seen it quite often, pontoon in the middle. Hoses sagging through. Interface between. There's a bit of an afterthought, right? Yeah. So, okay. Ship was built in Papenburg, right? Bunker station, traditional bunker station. Nothing fits. Doesn't fit at all, right? Nothing additional. So everything which is related to safety has to be on the other side, which is already a bad move, right? It should technically have a quick disconnect. They don't have enough space here, so they actually do a flange-to-flange connection, which is like absolutely every time they have to get a flange like that up. Normally use a quick connect. Like Montec has, and then yes, they have the Trelleborg system, which is your system, right? For the coral methane is an older vessel, so they don't have it. So they basically with their system, you can see on this ship what is going on the bunker barge. The bunker barge can see on the other side, and you can have communication with the bridges on both sides. So you don't have to speak with anybody. Yeah, but the coral methane doesn't have that. So they see their own. There's a shutdown. Yes, there is. Also, completely overlooked during the design stage. Ventilation is here on the boat deck. Where do you think his vent pipe is? Yeah. What did I say? What you cannot smell? Yeah. And then of course, Papenburg, I can tell you straight away from the drawings. Intakes on the boat deck on the one side, exhaust on the other side. So it sucks right away in the accommodation. There's no gas detector, it's not required for the IGF code. So at the moment we're only bunkering on one site, but completely overlooked because nobody really thought about it. If I had a diesel bunker barge, very simple. If it would start leaking, I would smell it in the accommodation. So, but at the moment, not. Also, the interface here with the hoses. Yeah, this ship cannot get underneath here. These hoses get a lot of stress. These hoses are being cooled down. These Cutling hoses to minus 160. They lose their. Yeah, they become also more fragile. This is very simple, right? So they get, have less endurance. And then what happens, of course, they start slightly moving. That's normal. This is Barcelona, by the way. I have an excellent picture with a gas tanker of Mol on that site a couple of years ago. With a big face. But good. Get stress. So what happens is these hoses start leaking. Right? And then, of course, for the time being, they put like sleeves over it, but it's not clean. So there's a long way to ahead of bunkering. Yeah? Another operator, like MSC, they have another problem. Because they pick up passengers in every port. In different ports. Sending somebody with a cigarette here. Didn't think about it, eh? They didn't think about it, yeah? So, of course, with my company as well, they freaked, so the security ones now that all the balconies are automatically locked, they want, because it's a problem, right? It can happen. Yeah? So MSC, they have changed it a little bit. So they started from the bunker station. So they basically have gonna have two DP2 bunker vessels. So they don't even have more. And they basically use an ARTA flexible pipe. Basically shove it into the bunker station. They close the bunker station, inert it. They reduce the oxygen content. And it's a double wall pipe. Bit more expensive, of course, because, but yeah, it's what you pay. But the bunker station is completely organized to do that. But that was done pre-designed and not like on the back end. Yeah? Also, what they realize as well, the bunker speed is way too slow. So at the moment, they have to do Barcelona and also in like the Canary Islands. The problem with the Iona is going to be in Southampton. They have the bunker. They haven't really moved on very much with Southampton with the bunkering at the moment. Yeah? But they will only have one port, and then the bunker speed has to be. Yeah? Good. Was it more than? Yeah. Yeah. Come back here. So, vacuum insulated piping from the bunker station to the tank. That's a vacuum insulated pipe, double wall pipe. Vacuum insulated. LNG valves and breakaway coupling. So breakaway coupling in this particular case is on this side. If the ship separate, it basically will break away. There's no gas leakage. Yeah. Ship related controls, and then the emergency shutdowning to the supplier. Well, that's like what Trelleborg does.
So you're saying there isn't a same thing on the coral reef
No.
at this point? So, but they're using a pendant across.
Yeah.
Is it, sorry, which cruise vessel is this?
AIDA Nova. So
AIDA
AIDA Nova has all the equipment, but
Yes,
the other
so-
guys don't have it.
Yes. So it's essentially you're putting it down to control of pendant.
Yeah. Yeah. Because originally it was the Cardissa, right? So that is
Yeah.
completely, yeah. But it's a work in progress. Different bunker barges, getting more and more. This was the first one in the world, I think, without a pump. Now you get more bunker barges. Ships we can already see here. Cruise ships, ferries, Belarus as well, and they have the whole fleet redone now. Also, bunker barges, container vessels. Container vessels now doing simultaneous operation. Every day is a yay, we did another simultaneous operation. The fact is, what's going to happen when the fan mast is going to blow off? We know roughly where the hazard zone is, but there's gantry cranes. So I wouldn't get too excited because we really haven't worked that completely out yet. We assume that certain things happen, but we can have in the future problems with it. Because at the moment, you see them doing it with small ships, but of course there might be a bigger risk when you get to these larger container vessels. Truck here as well, yeah. Same interfaces you have in the tank. All right. I didn't hope I bore you too much for an hour. Was it more than an hour? My God.
Hey, ladies and gentlemen, if we could show our appreciation to. Do we have any questions?
Yes, just going to have one question.
Yes.
When typically, say,
Can't hear it back.
sorry, typically a vessel, say going across the pond from here to
Yeah.
New York or something, with say maybe a 28 megawatt or something engine.
Yeah.
You're probably looking 3,000-4,000 tons of fuel, something, or 100 tons a day or something
Yeah.
like that. So in terms of capacity, how much space needs to get that equivalent where the fuel oil you can put it in a double bottom tank? But if that's going to be powered purely by LNG,
Yeah.
capacity-wise, tank-wise, and storage-wise, how much room would you lose? The shipbuilder will have to, obviously, he's going to have to throw a lot more steel, isn't it?
Yeah, no,
He's gonna have to make
you
the
lose,
ship a lot bigger
like,
than-
it's a cylindrical tank, right? So you need to, as I said, I compared square box, right? Square box with square box. So if you do a cylindrical tank, plus you have to add another, I would say 50% on it.
Right.
Make sense?
So space-wise,
yes.
it's quite a large.
Yes, and then it depends also where you're going to store the tank, because you get in the decks, you need to also make sure that your vent trunks are bigger, because you also have to realize if you have to calculate that if you get a fractured tank, that you don't build any pressure up in that space. So you have quite substantial trunking as well.
So these tanks don't go right in the double bottom area or anything like that?
No, above the double bottom, right? But they need to be vented off to the open area, so you can't build pressure. Remember, 1/600. So you have to avoid it if you get a fracture, so that has to be calculated, and that in design, they make sure that there's no pressure buildup. Yeah, so
And they will all have to be double skinned, is it though?
no, that's like single. Like the space itself is single.
So with the bulkers and with the passenger ships and things like that, it's relatively easy because the ports are called and pre-arranged and things
Yeah.
like that. Are they imagining that carriers and tankers and other things will sail all of the time on gas?
No.
Or just in the environmental areas where they have to?
I would say okay. So there's a couple of things you have to be you have to consider, right? There's more gas vessels at the moment not selling on gas than are selling on gas. Yeah, but it's very hard to manage, because if I don't have gas in my tank, or if I went through the process, I will start boiling off, right, very quickly, and then at one stage temperature will collapse, and then I have to go through the whole process again. Yeah? So you see, like Dany, for instance, as well, this area where they work, they don't have any gas, so they basically decommission the tanks, and they basically mothball it. But in other areas, I would say you could like have a tanker that they can work in certain areas, but it takes a little bit of working out how you're going to manage it, right? And that's what the CMA is on as well. They are going all the way to China and back on one tank.
How big?
It's a massive.
What, burning gas all of the time?
Yes, and that's a massive tank.
What is the capacity?
Oof, yeah, I
I
was.
mean, you're looking at 10,000 cubes. I mean, that,
Massive.
15,000 cubes.
They're the CMA tankers.
Yep.
Yeah, so they use the oil gas tanks as well, instead of reliquefying it.
No, but what type of ship is that? Is
Container, boxboat.
LNG tanker.
No, he's talking about a
Container,
container
container.
ship.
CMA.
Oh,
Yeah.
sorry. Yeah.
CMA. I will send you all the details. We just got it.
I've got two main questions.
Yes.
For economical, so if you are steaming on, travelling on diesel, you're storing your LNG, you've obviously got your boil off, and if you do end up not reliquefying it instead of venting it to air, is that?
No, I wouldn't vent it in air. It depends on the solution. You could use it in a boiler.
Yes.
But then the problem is then you start getting a weathering of the gas.
Yes, the question is, then you've got your diesel oil and your LNG emissions at the same time. That
Yeah.
be taken into consideration.
Yeah, but that's what I said. You need to look at the whole
Yeah.
footprint. Yeah, CO. Yeah.
And to be honest, I forgot my other questions.
Okay, good.
So it's,
When we build LNG ships, they're built with a ship-shore interface,
Yeah.
so that when the ship is built, it goes to the sun's terminals and it will line up exactly. So now when ships are built to be fueled with LNG, are they going to be built then with a fixed interface so that they can load from any LNG vessel?
Sadly enough, there is some guidelines, but it's a lot of afterthoughts. It's terrible. I mean, I saw the ones in the Gotland ferries. I mean, it's just horrible. It's like not even thought about. So there's very bad interfaces, and it's just a matter of checking it. And every time they have to check it. The one I must say as well is the Eon bunker barge who is selling in Rotterdam now. That seems to work, but the Cadiz as well. It can't interface with nothing. So it's basically a useless piece of product because it can't. It's very heavy.
Are the cruise ships reliquefying there?
Yes, they can.
Isn't there a large power consumption associated with that?
There's always energy. So energy is required to do that. Yeah. So, but having said that, normal ship, cruise ship, the boil off rate is like they can be burned off in the boiler because they need boiler capacity as well. So they can handle it, but yeah, they have. If they don't use the engine on a regular basis, then they need to start reliquefied. They have the compressors on board. They have everything. Well, the question is, what are the emissions really? Everybody proves everything. Even like an LNG boiler, right? They said like, well, combustions are fantastic. It's questionable because it's not true.
But when they're reliquefying it, are they using a nitrogen relic plant?
Yeah. Full plant. It's all mini.
Isn't it more economical just to burn it, isn't it?
Yeah.
I remember when the Max Q Flex came out, they didn't use the relic plant for a long time, and because of the costs of relicking, so they said they just used the gas combustion unit.
The problem you have on a cruise ship, if you start going on high loads, you have so much steam production. So then you can't use the boiler, so the boiler is automatically shut down. Well, then you have a problem. So you can have a problem. I'm not saying that you can have a problem. You have to manage it. The way they manage it is like to use reliquefaction if necessary, but it's not the ideal solution.
The gas combustion is exceedingly efficient.
Yeah.
I remember when we used to carry LNG, and we had a problem with the temperature sometimes on arrival in Japan. And I was very fortunate to have a chief officer who came from LPG.
Yeah.
So he said, well, should we just burn the gas? So we got in touch with Gas, and they said, yeah, go ahead, just burn it. So we just went on to full fuel. So So we brought the temperatures down
Yeah.
every day by 0.1 of a degree.
Yeah.
We brought the temperature down of the liquid.
Yeah.
The Japanese couldn't work out how we arrived exactly at
Yeah.
the required temperature.
The only
They were
problem we have
happy.
now.
They were totally happy, you know. So.
But nowadays they're not that happy anymore because they have gas analyzers, and they will see that actually the methane is the one who boils off
Yeah,
first.
yeah.
So you see that the methane content, and then you have the same port. They start bickering about the bloody samples because you have your samples and they have. But that's the way to do it. Yeah.
Just one more question, please. What is driving this? Because from a commercial point of view, or is it the fact that eventually the fossil fuels are going to run out? So is this a long-term
No.
plan of the this?
No.
What is driving this? Is it purely environmental?
No, also the money. So because if you get the low sulfur, so if low sulfur gets, well, look at 2020, if that gets implemented, if this the heavy users start using low sulfur fuel, what is the price going to do? Having said that, with the LNG, it's like a stepping stone. It's a stepping stone. You see now also fuel cells. There's a whole process in place to move out. So you see now as well, everybody now MSC says fuel cell, fuel cell. Yeah, the fuel cell runs much better on LNG, yeah? So or even on a methanol than on a diesel oil. You can use diesel oil as well.
But surely fuel cells, in terms of the power requirement, it's infancy, isn't it, relatively speaking?
Shore side, you can go already to 1 megawatt. Easy.
But 1 megawatt, that is not exactly a power required for a ship.
No, of course, no, you need much more power, but it's not a supplement. I still think that like the big driver is to be clean in port, and that's it. Like what they do in the ocean, well, that might be not on there, but they want to. But in port they want to look clean because ports are going to be more stricter and stricter, and it's quite easily done. And then you say, well, it's a passenger ship, and you see these Norwegians start now kicking off left, right, and center. So, well, do we really need a cruise ship in our port? And of course, the defense then of course of these cruise lines are going to be, well, we are so environmentally friendly. Yeah? So they have to move anyhow, but I don't think that LNG is the end.
So
I think it's just
the general consensus, especially for passenger vessels, would be that when they come into port or the vicinity of a place, they'll go pure LNG, and then when they get on the high seas, they burn the crappiest fuel going. Is it?
no, they're not crappy, but they can change over to it because then also your maintenance costs go up. But I wouldn't say they're crappy, but yeah, low sulfur, like or diesel. Yeah, or even heavy fuel oil. But they have to look at these things. But the biggest drive is the port. There is no.
Any other questions?
Are there any problems with fuel?
Lots. The one problem I can tell you, it's cruise ships is not the problem, but I can foresee with bulk carriers. If I do an Atlantic crossing and I go on LNG the whole time, if I come near the port, I would definitely recommend my captain to switch over, because these injectors haven't been used. So like the ones that you have 2 injectors, they haven't been used for 2 weeks or 5 days, 6 days, and they get carbon. As soon as you switch over, boop, you lose your engine. That's it. So yes, there's issues. So in preparation to go ashore to a port area, I would put it in my checklist to test.
Okay, ladies and gentlemen, we could just show our appreciation once more.